Hey there. So at this opportunity, you got at this point, you guys have had an opportunity to work with function operations, a variety of different function operations and applications with that over the last few days, week or so. So you have some pre-recorded lessons that you could go back to with function operations, and then one introducing compositions. And you can also use the resources and reference the resources that we used during the class sessions where we talked about and went more in depth with both operations and composition and started to look at domain. So in this lesson, I am really trying to give you guys an opportunity to extend upon this even more and gain a deeper understanding of all operations. So that's addition, subtraction, multiplication, division, composition, and look at some unique and somewhat more rigorous functions. So really gain this more in-depth opportunity or understanding of this. So let's go ahead and get started, and hopefully you guys have your notes out. So we're going to start with this, and we're going to do all the operations with these functions, but I'm just going to put up two at a time so that I can really show it. And then we are going to be taking a look at Desmos. So you guys have access to this PowerPoint, so you can even go to this link and see it, I believe. And it's not that mean, don't worry. So you've got f of x and you've got g of x. So we're going to perform the indicated operation, simplify, and then write down the domain, right? So remember, domain you want to think about before you even simplify. So you know what I'm going to do right off the bat? Anyone got a guess? I'm going to find the domain of f and g. So my domain here, right, this is, I don't love how this is written, right? That's 5 divided by x. Well, you can't divide by 0, so x cannot equal 0. It's everything but 0. This one's all real numbers. So don't forget that the restriction is where we're really starting from. So let's see what happens. So let's add f and g. 5 over x plus x squared minus 2. Okay, let's do some simplifying. Let's get them a common denominator. X, let's get them x as my common denominator. This is fun, right? It's not as simple as some of the others. So I'm going to multiply this by x over x. I'm going to multiply this by x over x. And then I'm going to have 5 over x plus x cubed over x, common denominator, minus 2x over x. And then we can combine and do some rearranging, right? Highest power first. X cubed minus 2x plus 5 over x. My final answer. So I'm going to do the domain from where it was right here. I have an issue. There's my issue. So your domain here is that x cannot equal to 1. It's everything but 1. You can write that as negative infinity to 1, 1 to infinity, if that works. Or all real numbers except for 1. What about this one here? F of x minus g of x. So 5 over x, we've already done half the work for this probably, minus, careful, x squared minus 2. I would make sure that you're putting parentheses. And remember, I should be able to find the domain right now. I shouldn't have to simplify. I could switch this order, right? Maybe write down the domain and then simplify. Maybe that would even be better, right? So my domain automatically right here, there's my issue. X cannot equal to 0. Oh my gosh, I said 1. I hope somebody was upset with me. Right, or again, negative infinity to 0, union 0 to infinity. So when I'm now going to simplify this, again, I'm going to find that common denominator. So I'm going to have 5 minus x, 5 over x, minus x cubed over x. And then be careful, you're distributing that negative, plus 2x over x. So if I rearrange this, I've got negative x cubed plus 2x plus 5, that should be an x, all over x. So just be mindful of that distribution. So there's some addition and subtraction. And we can take a look at this stuff on Desmos after the next view. And then our favorites, multiplication and division. Let's go ahead and write these again. X does not equal 0, and this is all real numbers. 5 over x times x squared minus 2. Let's do some distribution. And remember, I should be able to find it right here. Right here, domain. X does not equal 0. Right? We know it right away because let's see what happens. 5 x squared over x minus 10 over x. We can simplify this one, can't we? 5x squared divided by x gets you 5. Well, I don't know if I want to do that actually. Maybe I don't. Maybe I just want to write these two together. 5x squared minus 10 over x. Yeah, I'll just do it like that. I want it to be one fraction. I was going to simplify this and say 5x, but why would I do that? That's silly. And then this nice one. X squared minus 2 divided by 5 over x. So again, we do want to remember that right here, something's stopping us. We can't divide by 0. But is anything else? Like maybe I also need to look at, well, 5 over x can't be 0. That whole fraction can't be 0. Wait a minute. It will never be 0. Will it? No, there's an asymptote actually there at 0. It never actually reaches 0. You can't, if I start with 5, I can't result in 0. Right? No matter how many groups I want to split 5 up into, I'm always going to get a part. Like I'm starting with 5. I can't ever result in 0. If I have 5 of something and I give each person a quarter of it, like people are like, it's not, that won't happen, right? So like no matter what you do, you'll never get 0. So that's a non-issue for us. So here we've got the domain already. And we can look at the graph again momentarily. Instead of dividing by a fraction, I'm going to go ahead and I'm actually going to multiply by the reciprocal, which is x over 5. And then I'll go ahead and distribute. And I'm going to get x cubed over 5 minus 2x over 5 equals x cubed minus 2x over 5, right? That's where it becomes so important, again, that we looked at the domain all the way back here. We looked at it right from the beginning because we need to remember where it came from. It doesn't just lose properties. Whereas if we started with this, there would be no restrictions. If I walked over to you and I said, hey, find the domain of x cubed minus 2x divided by 5, it would be all real numbers. But it's because of where it originated from. It's what developed it. So I'm going to break here, not break, that's not the right word, and we're going to look at Desmos. And so I want you to see what our starting functions were. 5x, this is a reciprocal function, or a rational function. Let's look at presenter mode, projector mode, right? Well, how cool is that? So if I zoom out, 5 over x, it actually has a horizontal asymptote and a vertical asymptote. That vertical asymptote comes from this. So like really you're learning about vertical asymptotes almost from some of these restrictions when you're dividing by 0. If you do g of x, you get x squared minus 2, right? Many of us knew that this was a parabola. When we add them, this is what it looks like, right? And we said that the domain here was that x does not equal 0. That was the domain for all of these, right? So you can see as I go all the way up here, do you see how like x, it's getting super close and it never actually reaches it. You can even see some of those x values. If I go down also, again, right? How neat. You can also do this on a graphing calculator. Let's look at it when we subtract it. Whoa! See again, it's getting really, really close when it never touches. And if you go up, it gets really, really close when it never touches. Multiplication. Again. Oh my goodness, how crazy. And then this is the one that maybe wasn't as clear to us, this division. See? See how that works? It's getting really, really close to it. It never touches it. And you can like click on it to see how close it's getting, right? Look at that x value and go up as well. It gets a little hard to see. Maybe you need to zoom in more. These look really fine. And that's also a great way to check your work. I could type that in and then I could go ahead and type in what I got over here, that x, and you're gonna see they behave the same way, but this one will equal to 0. It's pretty cool. Amazing. So we're going to go ahead now and we're going to do composition with these two. So hopefully you remember some composition. F of g of x. Remember, this can be written as f of g of x, and that doesn't mean multiplication. That's composition. So I'm going to be plugging in g of x everywhere I see x in my f function. So 5 divided by x squared minus 2. And remember, this has a domain of all real numbers. Oh, no, it does not. This has a domain of x does not equal 0, and this has a domain of all real numbers. So this actually doesn't simplify anymore. But I want to, that's pretty much all I can do. I want to take a look at this and be like, wow, what can my denominator, I need to figure this out now. X squared minus 2 cannot equal to 0. X squared cannot equal to 2, right? I just can't divide by 0. X cannot equal to plus or minus the square root of 2, right? So if you want to write that in interval notation, I'm going to end up with something from negative infinity to negative root 2, negative root 2 to positive root 2, and then root 2 to infinity if you really want to do that. It's not going to equal, you can say all real numbers but these as well. Right, so let's take a look at f of g of x. Whoop. Right, so I can't really see it that well because I don't know it. But there's like this asymptote. You know what, actually? Let's go ahead, stop, and type in x equals negative square root of 2. And you see, like, I get this line. How neat. That's actually my asymptote. I can find it, and I can see that I'm getting exponentially close to it. And I can do the same thing. These are great ways to check your work, my friends. Actually, and to make sure that you have a really in-depth understanding, check that out. All right, so those are my asymptotes. And finally, I'll save that so you guys can click on it. We're going to find g of f of x. So here, domain, let's see if I can get it right this time, doesn't equal 0. All real numbers. I'm going to take this and stick it right in there, plug it in there. 5 over x squared minus 2. I want to, what do I need to do right now before I simplify it? I should make sure that I find the domain. Well, here is my issue. So x can still not equal 0. That is going to be my restriction, right? My restriction turned into something else when I did f of g of x. Here, look at it before you even simplify. When I simplify, that squared goes to both parts. 25 over x squared minus 2. I think I'm going to go, which I guess I would be able to figure out at this point. I'm going to multiply this by x squared over x squared, so I have a common denominator. 25 over x squared minus 2x squared over x squared. And then I think I'm going to go ahead and combine them. Negative 2x squared plus 25 divided by x squared. I'm going to go with that as my final answer. And then let's look at that graph. So we said it can't equal to 0, right? Which one was that? F of g of f of x? This one. Can't equal 0. Let's zoom out, zoom out, zoom out, zoom out. Zoom out. You can see what's happening. They're never actually going to meet. They're just going to get exponentially super, super, super close. Amazing. So, I'm not going to torment you guys or anything, but if we were in class, we would be doing this activity called a snowball fight, but we can't. So I still wanted to provide you the resources that we would have used for it. I really tried to come up with an idea of how I could have done it virtually, and I couldn't. I just figured we would do something else fun virtually, and I would just talk about the snowball fight. But you guys have access to the snowball fight problems as well as my answer keys. I'm going to do one with you now, and then I encourage you to go in and use them. Okay, so here is a snowball number 7. I literally just took a direct screenshot of it. And I'm going to go ahead and do this with you. And what I've said when I've done this in the past is that even though this is telling you this operation, it doesn't mean that these aren't great problems to practice with. We are going to also find domain with these, I believe. Yes, I'm going to. I think. Let me decide in a moment. So this is g of f of x. Let's see. So I'm going to be plugging in f into g. So 3 minus 1/2. I don't like the order that I wrote that in. 4x squared minus 3 squared. Oh boy. Right? Actually, what's the domain? All real numbers. There's no restrictions. It looks more complicated than it is. So 3 minus 1/2. I'm going to square this. Remember that this is 4x squared minus 3 times 4x squared minus 3. So that's going to be 16x to the 4th minus 24x. Oh, that's a 4. X squared plus 9. And then I can distribute that 1/2, which works out so nicely until the end. 3 minus, I mean, it's the negative 1/2. 8x to the 4th plus 12x squared minus, I'll go with 4.5. So finally, I got negative 8x to the 4th plus 12x squared. 3 minus 4.5. 3 minus 4 is negative 1, so negative 1.5, or negative 3/2. And that is what I get for this composition, right? So these are still great. Like if you want to practice addition, subtraction, multiplication, division, you have these pairings. And while there isn't an answer key to that, that is a great thing to practice. And if you want to check in with your teacher and see if you're doing them right, I highly encourage that as you're moving forward. So in this lesson, we looked at some more rigorous problems, right? We hopefully really gained a deeper understanding of all of the operations. I didn't want to just focus on composition. I wanted you to see them all and how they can all get a little bit more in depth and a little bit more unique and rigorous. And we can look at them and see what the impact of an operation has on the domain and really like use the graph, use Desmos to check it. And if you need to go back and rewatch anything, go for it. I encourage you to use the Snowball Fight resources to practice and any of the other resources, as well as complete your assignments. Thank you everyone for watching.